Okay. Bismillahir Rahmanir Rahim. Okay, Bismillahir Rahmanir Rahim. Okay, I'm gonna repeat what I just said because now I'm recording. We have actually completed this chapter of acids and alkalis, and this chapter 10 in your book. It is chapter 10 in my book. I have an old book. I don't know what the chapter number is in the new book, but I have completed the chapter of acids and alkalis, and we have covered acids and alkalis and neutralization reaction and what is a salt and how do we prepare soluble salts. We did preparation of soluble salts only. We did not do preparation of insoluble salts. And I believe in your the revised scheme of studies, this chapter is only till the preparation of soluble salts. It does not include the solubility. It does not include the preparation of insoluble salts. So I don't know if I should do it. So we will decide that later. First, let's revise what we have already done, and let's also revise what will be coming in your exams, right? What is included in your scheme of studies. So since we have completed this chapter, I will start with the end of chapter questions. Maybe we did 2 of them already. So, but we will do it again. We will start from the scratch. We will do the questions, okay? So I want you to take out the end of chapter questions in your book. Is there anybody in this class who does not have a book with him? If there is anybody who is without a book right now in this class, please raise your hand. Then I will share my video. I'll show you the question in the video. But if everybody has it, then it's fine. I don't need to. So if there's anybody who does not have a book, please raise your hand. Okay. Ishan, you do not have a book? Ishan, you don't have a
Teacher,
book?
I have a question actually.
Okay,
I have
okay,
a
go ahead.
question actually.
Yes.
Teacher, I have an old book. Are we gonna do the question answers?
In your copy?
No, I mean book.
Yeah, we are going to discuss questions from your book. Yes.
Okay, since I have my own book, so my book will be written answers.
The answers are already written?
Yes.
It's okay. I will ask you why. We will discuss why. Because, you know, the answers are even there on the net. I'll show you. I'll show you. The answers are even there on the net. You can search on the net, and I can also share with you guys. Another thing
Okay.
I have, yeah. So the point is not to know the answer, the correct answer alone, but you should know why that answer is correct. Okay, that's more important. Okay, and another thing, I have invited other people as well to this meeting, to this class. Okay, I have invited grade 6 students from other sections. So you might see participants in this class who are other than your sections. Okay, so don't worry. Okay, question number 1 in your book. Copy and complete, and then they have given you fill in the blanks. Acidic solutions turn blue litmus. Now, if there are any students who have not done this chapter with their teacher and they were not with me in my previous classes, which I have taken online, then you might not be able to understand me. But you can stick around if you still think that it's helpful. Otherwise, I will revise this chapter again, but in the next classes, okay? Not now. Today, I will do these questions at end of chapter questions of acids and alkalis. Okay, so question number 1. Who is going to read question number 1 for me so that I know that you guys have the same questions as me? Okay, Hassan. Yes, Hassan.
Copy and complete. Acid solutions turn blue litmus paper red.
Red? Yes. Why?
Because of
Hassan?
its pH.
Yeah, because of the pH. What happens to the pH?
It is below, I think so, 7.
Huh?
The pH, it is below 7. So below 7, all the colors are dark, which means red.
Yeah, not dark, red. Okay,
Yeah, because of this
blue litmus turns red when the pH falls below 7. 7
7
means 7 means neutral.
neutral.
And what does pH mean? What does pH mean? I discussed this. What does the term pH mean? Yes, Ishan, what does the word pH stand for? Yes,
Yes, teacher, means power hydrated or power hydro.
Ishan. Now, it's not only for Ishan, it's for everybody. See, if you will just come here, attend the class, and then that's it, these classes won't help you. I told you, read the book before you attend the class and then after attending the class. Before attending the class, the book will give you ideas of what can be discussed in the class. And then after you have understood, then when you will read again, you will understand things better. Okay? So otherwise, if you're not reading book and you're just attending this class, these classes won't be that useful for you. Okay? In the last 2 classes, I repeated what pH stands for. pH stands for who else? Because I really can I'll give the answer out, but I don't want to. Oh, Riaz. Oh, okay. Yes. Okay, Riaz.
Yeah, it stands for potential of hydrogen.
Good job, Riaz. Were you there in my last classes?
Yes.
Yes, good job, Riaz. Yes, you have made me happy. You have pleased me. Jazakallahu khairan. Yes, but pH stands for potential of hydrogen, which means in indirect terms, it means concentration of hydrogen ions. Okay, this is advanced math. We don't have to deal with it. Just understand that potential of hydrogen is just another way of representing the concentration of hydrogen. Okay, so highest concentration of hydrogen ion would mean lowest pH, which is 1. And highest concentration and the lowest concentration of hydrogen ions, or in other words, highest concentration of hydroxide ion would mean pH of 14. And when we do not have any of the, when we do not have any of the ions, or if we have equal hydrogen ion and hydroxide ion and they react together to give us water molecules alone, I'm saying water molecules. So there are no ions, no hydrogen ions available. Then the litmus paper would be, I'm not talking about the litmus paper, but the universal indicator would give you green color, which is neutral. Okay. By the way, litmus paper is an indicator that can only turn either blue or red. So blue in alkaline and pink or red in acidic, but it does not have any separate color for neutral pH. Okay. Okay. So acidic solution, and I'm not going to revise the definitions of acid and alkali. I revised it many times, so I'm not going to repeat myself. Okay. So let's move on with the question. Acidic solutions turn blue litmus red. Okay. Ishan answered that. Their pH is always dash then 7. Dash then 7. Yes, Arif Tariq. Yes,
They are less than 7.
very good. Good job. Okay, let's move on. Then here are their common reactions. Acid plus base or alkali gives salt and what else? Yes, Hassan Ahmad. Yes,
Water.
good job. Okay, let's move on. This is easy. Acid plus carbonate gives us salt, water, and yes, Ishan. Yes,
Carbon dioxide.
good job. Carbon dioxide. Carbon dioxide comes from?
Um, Carbon dioxide comes from the carbonate.
Good job. Good job, Ishan. I like it. Good job. Okay. Acid plus metal, salt and salt and, yes, Arif Tariq. Yes. Yes, Arif Tariq.
Acid plus metal gives us salt plus hydrogen.
Good job. Why hydrogen? Why hydrogen? Yes, Arif, Ibrahim. Yes, Ibrahim. Why, when acid reacts with metals, hydrogen is released? Yes, Ibrahim. Yes, Ibrahim. Ibrahim, you're unmuted. Okay. Shahzeb. Yes, Shahzeb.
Teacher, I wanted to ask you that can you tell again from the question, I mean the fill in the blanks from beginning?
Beta, I'm recording my class. Okay, I'll share the link, and whatever you have missed, you can get it from the recording. Okay, because you know we are already short of time. I'm taking only 1 hour class, so okay. 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 So now answer the question: why is hydrogen released when acid reacts with metal? I can see 3 hands raised, but when I'm unmuting them, they are not answering. Anybody else? Okay, then I'm going to explain this to you, because you know I don't want you to just memorize, but I want you to understand. Okay, I am sharing my video. I'm sharing my video. Okay, so when you have an acid, for example HCl, and let's suppose we make it react with, let's suppose, sodium. Don't do it practically, this is very explosive reaction. Okay, I'm just giving you an example for explanation purpose. Okay, so that now looking at the reactivity series, do you know the reactivity series? Sodium is way more reactive than hydrogen. So sodium would displace hydrogen out, giving us sodium chloride plus hydrogen. Hydrogen will be left behind. Now if I want to balance it, I have 2 hydrogen atoms here, so I will add 2 here because I want the hydrogen atoms to be balanced, and in doing so I have twice the chloride, the chlorine atom. So if I want to balance that, I will have to add 2 here to have 2 chlorine atoms here, and then that makes sodium 2. So in order to balance 2 of sodium, so 2 hydrochloric, 2 sodium, giving me sodium chloride and hydrogen. So that is why hydrogen gas is released. Okay, the reason why hydrogen gas is released is because the reactive metal displaced hydrogen, because sodium is way more reactive than hydrogen, way more bossy than hydrogen. So it kicks it out. Hydrogen is released as a gas, forming salt. So remember the 3 methods of producing salt. One of them was acid with metal. And so we get a salt. And this is soluble salt. Okay, soluble salts. And in the process, hydrogen is released. Remember we did this? Okay. Now I'm telling you, you got to revise. Okay, you got to revise. If you do not revise, no matter how many classes you attend, they will not be useful. Okay, please try to understand this. After attending the class, sit down with your book, read it again. Okay, read it again. Understand it in your own way. Okay, read different authors' books, read as much as you can, or at least read your course book, at least. Okay, so now you understood why hydrogen is released? Okay, let's move on. Okay, who's going to recap for me the 3 methods of preparing soluble salts? Who's going to recap for me the 3 methods for preparing soluble salt? I can see 1 hand raised. Who is going to recap for me the 3 methods for preparation of soluble salt? Come on. Come on. Yes, okay, Ibrahim. Yes, good job, Ibrahim. Yes.
The three methods are number 1 filtration, number 2 evaporation, number 3
These are methods of separation, mera beta. These are methods for separation, not preparation of soluble salts. You are giving me methods of separation. Who can tell me? Hassan? Come on, Hassan. You want to try? Beta, I don't like this. I took 2 classes on this. Why? Why can't you guys recap? You guys are staying at home, right? You don't have to go to school. You don't have to go anywhere. You're at home. You have all the time in your hands. Make use of it. I don't like this fact that you guys have not revised. I am not happy, okay? Yes, Ishan?
Teacher, I'll give it a try. Just maybe
Okay.
it's like acids, neutralization, and salts.
Neutralization. Well, yes, neutralization is one of the methods. It is one of the methods. Okay.
Maybe so then neutralization is one of the methods. So then
Okay.
then what about like acids?
Okay, move. Okay, can you get on that page? Can you get in your book, get onto that page which says preparing salts? I don't know what page number is that in your book, so I'm not using the page number. Okay, this. Sorry, yeah, this page. Take this page out. Keep your eyes on the video that I'm showing. This page, I want you to take this page out. Preparing salts. Can you see this in the block highlighted? As these are the 3 methods: 1, 2, 3. These are the 3 methods of preparing soluble salt. Soluble, okay, remember soluble. This is neutralization, Ishan, that you just mentioned. Acid plus base giving salt and water. This is one method of preparing soluble salt. This is another one, acid plus carbonate giving salt, water, and carbon dioxide. Third is this, acid plus metal giving salt and hydrogen, where the metal has kicked the hydrogen out of acid and that hydrogen is given off as a gas. These are the 3 methods of preparing soluble salt. Please remember this: neutralization, acid plus base giving salt and water, acid with carbonate, acid with metal. Okay, so in all the 3 methods we are using acid. In all the 3 methods we are using acids: acid plus base, acid plus carbonate, acid plus metal. In this, salt and water are produced. In this, salt, water, and carbon dioxide. Carbon dioxide comes from the carbonate. Here, salt and hydrogen is produced. You understand that? Okay, so these were the 3, and we discussed in details their experiments and everything. Okay, then move on. So these are the 3 methods they have enlisted here in this question. Okay, so acid plus base, acid plus carbonate, acid plus metal. Okay, when an acid and alkali react to cancel each other out, we call it a dash reaction. Now, why have they written cancel each other out in inverted commas? Cancel each other out means like hydrogen ions, I'm answering myself. Hydrogen ions react with the hydroxide ions. This is what they mean by canceling each other out, which by the way is also an ionic equation for neutralization reaction. Hydrogen ions reacting with hydroxide ions to give water molecules. Okay, yeah. So this is called cancel each other out. Okay, this is what they mean by canceling each other out, meaning hydrogen ions reacting with hydroxide ions giving water molecules. So at the end, we do not have any hydrogen or hydroxide. All we have is neutral water molecule. Okay, this is what they mean. So this reaction is called what? What is this reaction called? What is this reaction called? Hassan. Yes?
Neutralization reaction.
Yes. Yes. Good job, Hassan. Good job. Jazakallah khairan. Oh. Okay. Then question number, then this table. A salt is made when the dash in an acid is replaced by a dash. Yes. Who wants to answer? Yes, Hassan. Yes.
The hydrogen in an acid is replaced by a metal.
When the hydrogen ion in an acid is replaced by metal. Perfect. Perfect. Yes, perfect. Okay, now let's come to this table. Let's come to this table. Hydrochloric acid will give us what kind of a salt? We did this in the last class, remember? Acid will determine the type of salt, remember? In the last class. Why? Why will the acid? Yes, wait. Okay. Who wants to answer? Riaz. Yes, Riaz.
Chloride.
Yes. Chloride. Good job. Why?
Because the
Yes. Hurry up, hurry up, hurry up. Okay, I'll answer that question. See, keep your eyes on the video. Now, did you see in this reaction, the metal, when it kicked out hydrogen, we got sodium chloride. An ion of the acid always comes from, sorry, an ion of the salt. I'm so sorry. An ion of the salt comes from the acid. Anion of the salt comes from the acid, and it is the anion of the salt which determines the type of the salt. Like this is a chloride, you know, just like you are recognized by your father's name, right? Your last name. Same way, these salts are recognized by their last name, and their last name is the anion, chloride. Now, of course, this chlorine atom came from the acid. So it is the acid that decides what the salt will be, no matter what the method of preparation is, whether you used an acid and an alkali, meaning you use the neutralization reaction, and then see. Now, again, this came from the acid. Even if you use carbonate, for example, HCl plus, let's suppose, sodium carbonate, you will get, again, NaCl plus water plus carbon dioxide. So you got this chlorine from the acid. So acids decide the type of salt. Acids decide the type of salt. Acids decide the type of salt. Remember this, okay? Alkali decides the sort of cation. The alkali decides the type of cation, or metal will decide the type of cation, or in this case, the carbonate, meaning the other reactant would determine the type of cation, but it will only be the acid determining the type of salt or the anion in the salt. Okay, now, then let's move on. Sulfates will be from then which acid? Sulfate will be from which acid? I want some new participants. Muhammad Wali, good job. Yes? No? Okay. Okay, so okay, Hassan, you tell me. Yes?
Sulfuric acid.
Sulfuric acid. Good job. Okay. Nitric acid from nitric acid would form what sort of salt? Okay, Riyaz. Okay, Riyaz. Where is Riyaz? Yes, Riyaz.
they form nitrates.
Nitrate. Good job. Now, another question. Another question. When do you have, again, okay, when do you have 8 as your, when do you have 8 as the suffix in the as a suffix in the name of the salt? And when do you have "ide"? Remember, in the last class I mentioned this. When do you have "ate", like nitrates, sulfates? And when do you have the "ides", chlorides? Huh? Who wants to answer that question? When do you have "ate" and when do you have "ide" in the name of the compound? Yes, Ishan?
We can use it as for like if we can say sulfuric, so we can change it into whenever we like transfer acid into solid, so we say sulfurate. But whenever if we transfer like hydrochloride into an acid, salt, so we call it chloride.
No, beta, no. Sorry, no. Ibrahim, you want to try? Okay. You know, the reason why I'm asking you guys is because I've already mentioned it, not once but twice.
Teacher, we add 8 in a symbolic for in a word formula when we have 3 oxygen molecules present, and we add "ide" in a word formula when we have less than 2 or 2 molecules of oxygen.
Okay. Yeah, you know some rough idea, but not exactly. Okay, your answer is not completely correct. It is partially correct. Some of it is correct, but not all of it. Okay, now I'm repeating for the third time. Okay, you have 8 in the name of a salt when you have oxygen atoms in the anion. For example, sulfate ion. Okay, for example, if I say sodium sulfate, so can you see there are oxygen atoms in the anion? That's when you have 8 in its name. So it's called sodium sulfate. Okay, now when a compound is made up of only 2 elements, such as sodium chloride. Now the 2 elements are sodium and chloride. So I will write sodium chloride. You understand that? So ide when you have only 2 different types of elements in a compound, in a salt. And 8 when you have oxygen atoms in the anion. Remember this, okay? So nitrate. So when I say nitrate, now again, there is 8 in the suffix, right? Why? Because, let me write sodium nitrate. Sodium nitrate. Did you understand? So can you see oxygen atoms in the anion? You know this is the cation and this is the anion. You know this, right? Right. So when you have oxygen atoms in anion, that's when you have 8 in the name at the end. Okay, I hope this is clear to you guys. This is also mentioned in your book. Okay, now most of the cations are metal cations except for one. Most of the cations are metal cations except for one. Which one is that? Does anybody know? It is mentioned in your book. It is mentioned in your book. Okay, yeah, but it is mentioned in your book, this one. This exception to the rule, this page. Look at this page, naming salts. What is a salt? Exception to the rule. Here they have talked about ammonium. Ammonium is a cation which is not a metal, but it is still a cation, meaning it is positively charged, ammonium ion. This was just out of the way. Okay, let's move on to the questions that we were doing. Okay, so now you know why we call them 8. Okay, and when do we have this ic acid? Ic acid. When do we use ic acid in the name? When the acid is aqueous solution. If, for example, you have only hydrogen chloride, with no water, if this is not dissolved in water, this is just hydrogen chloride, then we will call it hydrogen chloride. Simple hydrogen chloride. But when it dissolves in water, it forms hydrochloric acid, meaning it forms a solution. So we write it this way, aqueous. AQ meaning in solution, dissolved in water. AQ is short form for aqua. Aqua is a Latin which means water. Okay, so don't be confused. So when do we have ic acid? When the acid is dissolved in water. Okay, an acid is an acid only when it dissolves in water, right? An acid is an acid only when it dissolves in water. Why? Why is an acid only when it dissolves in water? Anybody wants to? Yes, Ishan? Yes?
Acid is only like whenever it's below 7, so we call it acid once we go down from the main 0.7, so it started becoming acid.
Okay, Hassan, you wanna try? Yes? An acid is an acid when it is dissolved in water. Why?
Acid, because you told us right now aqueous, and aqueous means dissolved in water. And example is hydrochloric acid.
Yeah, but my question was, see, if you have hydrogen chloride, for example, if you have hydrogen chloride, your eyes on the video. Yeah. If you have hydrogen chloride, and this is only hydrogen and chloride, that's it. Okay.
Yes.
Then there is no water, only hydrogen chloride bonded together. That's it. Do you think this is an acid? Then it will behave as an acid? Do you think it will behave as an acid if I have only hydrogen and chloride bonded together? Huh? No. Water molecules will separate them into hydrogen ions and chloride ions. Because it will be the water molecules which will separate them. See, hydrogen and chlorine are bonded like this. Okay, they are bonded. This is hydrogen atom, this is chloride atom. They are bonded together. Now water molecules will come along. They will come along. These triangles are water molecules. Okay, just imagine these B's are water molecules. Now these water molecules will, I'm sorry, I got this wrong. Sorry, I'm making another one. Okay, like this, and this will be like this. Okay, here are the hydrogen atoms, because hydrogen atoms are the positive part of the molecule, so they will be attracted towards the anion because it has negative charge, and because it has positive charge, the negative part of the water molecules will be attracted towards it, and so they will take them away. These water molecules will take this hydrogen ion away. These water molecules will take these chloride ions away. So now they have been separated and they will be surrounded by water molecules this way. You know, like ek dusre se dosti chhod do, humse dosti kar lo. You know, the water molecules got separated them. Aapas mein katti kar lo, humse dosti karo. Okay? And then they have surrounded these cations and anions. So the water molecules have separated them. Now this hydrogen ion is separated from chloride and is available to behave as an acid. Remember the definition of acid are substances that give hydrogen ions in solution. Solution meaning in water. In water, meaning that they can give hydrogen ions in solution with the water. Okay, so this is what I meant. So that is why acids are acids only in water, when they dissolve in water, because that's when they release hydrogen ions. And until and unless they cannot release hydrogen ion, they cannot behave as an acid. because acid is basically due to hydrogen ion. Acid is acid due to hydrogen ion. Okay. Now, did you guys understand? By the way, I am not explaining this for the first time. I have explained all of this in the last 2 classes. And today I'm a little disappointed to see that you guys don't know what I taught you guys in the last 2 class. But anyway, okay. Question number 2. Copy and complete these word equations. Sodium hydroxide plus acid giving sodium chloride and water. Even I have the answers written, but that's okay. Now, salt is what? Chloride, right? I told you the anion comes from the acid. I told you the anion comes from the acid. So if the anion is chloride, we want an acid that has chlorine in it. We want an acid that has chlorine in it. And the 3 most commonly used acids are given in your book, first page of this chapter. These are the 3 most commonly used acids: hydrochloric acid, sulfuric acid, nitric acid. Remember their formulae. It's very helpful. Remember their formulae. Hydrochloric acid, sulfuric acid, nitric acid. Okay. So if there is chloride, then must have come from, of the 3 acids, which one has chlorine? Of the 3, which one has chlorine? HCl. HCl has, so HCl. Okay, you got my point? Now, move on. Copper oxide plus sulfuric acid is giving us this 2. What are the products? What are the products? Now, of the 3 methods of preparation of salt, remember the 3 methods: acid plus base, acid plus carbonate, and acid plus metal. Of the 3, which type is this? This is acid plus, what is this? Is it a carbonate? No. Is it metal? No. This is copper oxide. So metal is bonded with something else. It is bonded with oxide. So then the 3rd one is left, which is acid plus base. So yes, this is a base. Okay, now you might ask me, but teacher, this does not have hydroxide in it. And I told you that for a substance to be a base, it is not important to have hydroxide. Okay, it should be a proton acceptor. A substance which is a proton acceptor is a base and will carry out the neutralization reaction with the acid to give you salt and water. Okay, so now in order to answer this question, you should be able, I would recommend that you write down the equation. Okay, write down the formula and the equation. Who will tell me the formula for copper oxide? Yes, Isam? Yes? Yes?
Teacher,
Yes?
I needed to ask you the question about the anion and cation.
Okay. Yes, go ahead.
I need to ask you about the cation and the anion because I am not familiar with it.
You don't know what,
Word. You with the wordings you are using.
you don't know cation and anion?
Yes.
Okay. Cations are positively charged particles, atoms that have lost an electron. And anions are negatively charged particles, atoms that have gained electrons. Okay, for now, I will explain only this because if I go into details, I will get deviated from this topic. Okay, I am right now explaining acids and alkalis. So if I will go into what cations and anions are, I will move away. All I can explain right now is that an atom, for example, if this is an atom, this is, okay, I'm doing it real quick, okay, so that you understand. Now, this is a nucleus of an atom. It has 2 protons and 2 neutrons, okay? Protons are positively charged. Neutron has no charge, okay? And for example, this has 2 electrons and each has 1 negative. So 2 positive, 2 negative, sorry, 2 positive, 2 negative, cancel each other out and we get 0, right? So this is a neutral atom. Now, if it loses 1 electron, or let's suppose, yeah, if it loses 1 electron, then it will be left behind with 2 positive protons, but this is gone, right? This is gone, only this is left. So -1. So +2 minus 1 is minus, sorry, +2 minus 1 is +1. So this will be a cation with +1 charge. Okay, now this is a cation. Okay, this is a cation. Now the anion, which is negatively charged, does the opposite. For example, it has 2 protons and 2 neutrons. So 2 positive charge, it has 2 electrons. Okay, now it gains 1 more. It gains 1 more. So now 2 positive and 3 negative. So what do you get? -1. So this is an anion, meaning negatively charged. This is all I can explain for now. Okay, I hope you understood. Okay, let's move on. Okay, so copper oxide plus sulfuric acid. Whoever is raising hand will also explain me why. Okay, so be prepared for the why. I don't want just the correct answer. I know you have answers written down in your books. I want to know why. That person should be able to explain me why. Okay, Riaz, or do you want to explain why? Okay, let me do this real quick. So I'm doing copper oxide. Copper oxide. How do you write the formula for copper oxide? How do you write the formula for copper oxide? Copper has a charge of +2, right? It has a charge of +2, and oxide has a charge of -2, right? +2 -2 get cancelled, so we don't write anything. So usually what we write is we write the charge of the anion close to the cation and the charge of the cation next to the anion. But when they are equal, they get cancelled, so we don't write them. Okay, so copper oxide is reacting with reacts with sulfuric acid. Okay, giving us, now the insiders react together, the outsiders react together. The insiders react together and the outsiders react together. So when the outsides react together, what do I get? Copper. I get copper sulfate. Okay, now sulfate has -2, copper has +2. So if I write 2 here of +2 and then I write 2 here, they are equal, so they will get cancelled. So I won't write them. Okay, I won't write them. So I have copper sulfate. Okay, and then the insiders. Insiders is H2O. H2O. So this is a neutralization reaction. This is acid. This, by the way, is a base, but it is not an alkali. It is a base, but it is not an alkali. Why? Because it is not soluble. Remember, alkalis are soluble bases. This is salt and this is water. Okay, so base plus acid giving me salt and water. Okay, so I got the answers, copper sulfate and water. Now let's move on to the next question, which asks me that dash plus sulfuric acid gives us magnesium sulfate. Okay, let me write down the formula. Sulfuric acid, we know, is H2SO4, giving me magnesium sulfate. What will be the formula for magnesium sulfate? The charge on sulfate is -2, on magnesium is +2. So they will get cancelled. So I will not write anything here, okay? Magnesium and sulfate. By the way, if you guys don't know how to write formulae, then let me know. I will arrange a class on how to write formulae. If you don't know how to balance an equation, you let me know. I will arrange a class on how to balance a chemical equation. So magnesium sulfate plus hydrogen. Okay, hydrogen. So now this sulfate came from here. We know that. This hydrogen got kicked out, and so it came here. But what kicked this hydrogen out? This kicked it out, right? This must have come from here. Must have come from here. So that means which metal reacted with sulfuric acid to give us magnesium sulfate and hydrogen? Magnesium. Okay, magnesium is the answer. Now, the reason why I'm not asking you guys and I'm solving this myself is because, you know, that's taking a lot of time, and there are many students here who have joined us for the first time. So, and we are running out of time, and this is only the second question. So let me just, explain you. Because you guys have the correct answers, you need explanation, right? Now, part E, sodium hydroxide. I'm doing question number 2. End of chapter question, acids and alkali, question number 2. Part E, okay? Sodium hydroxide. Now, I know hydroxide is one ion, okay? It is an anion. It has -1 charge on it. Sodium has +1. So get cancelled, so I don't write anything. Sodium hydroxide plus nitric acid. I know nitric acid formula is HNO3. Okay, now insiders will react and outsiders will react. Insiders will react and outsiders will react. Okay, so when outsiders will react, sodium nitrate. Okay, nitrate is -1, sodium is +1, get cancelled, so I get sodium nitrate. When the insiders react, I get water. Okay, so this is acid. This is alkali. This is not a base. This is alkali because it is soluble. Sodium hydroxide, soluble. I told you group 1 and group 2 compounds are soluble. Okay, this is salt. Now this is a nitrate. Why is it a nitrate? Remember, I told you it has oxygen in its anion. Therefore, the name has 8 in it, nitrate. And this is water. Okay, now let's move on to question number 3. Question number 3. Joe tested some solutions with universal indicator paper. He wrote down their pHs, but forgot to write the names of the solutions. Can you help him by matching the pHs to the correct solutions? Distilled water. Now, whoever will answer should answer me with the Y. Okay? Okay, Hassan. Yes, I'm unmuting you. Hassan, you want to answer? Hassan Nadeem Wali. No? Okay. You want to answer, Hassan?
No, actually, that will be for lower data.
Sorry? Okay. Hassan? Okay. Yes, Hassan?
Is distilled water pH 7?
Why?
Oh, because it is neutral.
What do you mean neutral?
In the pH scale, in the middle it's neutral, which means green, which means it's neither acidic, neither alkali.
Why? Why is it
Because
neither
it is-
acidic?
Because it does not react with anything.
Beta, ek main baat bataun aapko. When you answer in such a way that even a person who does not know anything about chemistry understand what you are saying. Okay, let me tell you something. You know what's the best way of learning anything? What's the best way of learning anything? Explain to somebody. Explain to somebody. Okay, when you explain to somebody, you have to understand it well yourself first. So when you will explain to somebody, first of all, you will understand it real well. You will grab a real good hold on it. And secondly, you will never forget it. Okay? So that's why I'm asking you to tell me why. Okay? Okay, can anybody else? I was saying it because I had a question, but now I forgot it. Ishan Ali, can I answer? Okay, no, but okay. Yes, Ishan.
The distilled water is 7, sulfuric acid is 1, sodium hydroxide is 14, vinegar is 5.
Ishan, I was interested in knowing why distilled water is 7.
Because it's the neutral. The 7 is the neutral.
What
7 is the
makes it?
neutral.
Okay. Now, let me put this question this way. When you're saying neutral, so what is pH? What is pH? Potential of hydrogen, remember? And I told you that any substance that does not, now pay attention to my words, that does not have hydrogen ions will give you pH 7. Any substance that does not have hydrogen ions will give you pH 7. So when I am asking you why, you answer me in terms of hydrogen ions. You will give me answer in terms of hydrogen ions. So you will say, okay, I'm now giving out the answer. Distilled water pH is 7 because it does not have any hydrogen ions or hydroxide ions. Because hydrogen and hydroxide ions have combined together to give us water molecules. Water molecules. So all we have in distilled water are pure water molecules. We do not have any hydrogen or hydroxide ions. Therefore, the potential of hydrogen is basically 0, which is equal to pH 7. Okay? Okay? A pH 7 meaning no hydrogen ions. pH 7 means no hydrogen ions. Okay, now tell me, what is the pH of sulfuric acid? Yes, you told me, Ishan, it was 1. Okay, thank you very much. Now, who is going to explain me why? Easy. This is easy. Sulfuric acid is easy. Its pH is 1 because it has what? Yes, good job, Hassan. I like it. Yes?
Because it has 2 hydrogen ions.
Because it has?
2 hydrogen ions.
Why are you saying 2? Okay, you're from the formula. Oh, okay. Yeah, no. See, the pH does not depend upon how many hydrogen ions in the formula. Okay, pH does not depend upon the number of hydrogen atoms in the formula. The pH depends upon the concentration of hydrogen ions in the solution. Okay, the concentration of hydrogen ions in the solution. Well, yes, you can say that concentration of hydrogen ions in the solution will be indirectly dependent upon how many hydrogen ions are there in one molecule, but yes, it has to do with the concentration. Okay, so you will say that the pH of sulfuric acid is 1 because the concentration of hydrogen ions in the sulfuric acid is too high. It is too high. That's why we got the lowest pH. Sulfuric, remember these 3 acids on the first page of this chapter, they are the strongest acids we know in ordinary practical chemistry. These are the strongest acids we know, and you will come across them throughout your O levels as well as A levels. Okay, then sodium hydroxide. What is the pH of sodium hydroxide and why? Galaxy M20. Yes.
Sodium hydroxide, the pH of it is 14 because the hydrogen ion concentration is too low.
Good job. What's your name?
Ibrahim Khalil.
Good job, Ibrahim Khalil. Oh, I was wondering where you are. Good job. I'm so proud of you. Yes, your answer is correct. the pH is 14 because the hydrogen concentration is too low. Now you might get confused that, you know, why is it that when the hydrogen ion concentration is 0, the pH is 7, and when the hydrogen ion concentration is high, the pH is 1, and when the hydrogen ion concentration is low, the pH is 14. You know, like the number of pH is the opposite, right? Right? Like it's like this. You might be wondering that when the concentration, when the concentration of hydrogen goes high, the pH goes low. Why? Or when the concentration of hydrogen goes low, the pH goes high. And when the concentration of hydrogen is 0, the pH is 7. Why? Now the why lies in advanced math. It lies in advanced math. Okay, you don't have to deal with it. Okay, you don't have to know it. Okay, but just remember that it is this way, that when the concentration of hydrogen increases, the pH decreases. Okay, this is advanced math. Do you know what this is? I don't know. We don't do that. That's part of advanced math, and advanced math is not given in this school, and therefore is not available, I think, in Riyadh. It has to do with logarithm. Okay, so you don't have to know this, but I am just mentioning this so that you don't get confused. Okay, you might have this question in your mind. Okay, then yes. Okay, now vinegar pH is 5. Good job, Ishan. Now can you tell me why? Who will tell me why? Can you tell me why? Can I tell the next one? Okay, Riaz, you tell me the next one. Yes. Okay, Riaz.
Yes, because its pH is 5 because the concentration of hydrogen ions are high but not that high.
Good job. Okay, and why is that? Why not too high? And what sort of an acid is that acid called? Such acids called? Which are high but not too high? What are such acids called? Anybody knows? Anybody knows what are such acids called which are edible, meaning we use it in food? So hydrogen ion concentration is there but not too high. What are such acids called? Yes, Galaxy M20. Yes,
I
Ibrahim.
think weak acids.
Weak acids. Good job. These are called weak acids. Why are they called weak acids? What do you mean by weak acids?
Because
Yes.
because from 4, 5, and 6 they become weak, and 1, 2, and 3 are the strong acids.
Okay. 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 Let me give you a little. I don't know if has the book talked about weak and strong acids? Have they talked about it? Or okay. Let me just give you a real quick what we mean by weak acids. Now this is the acid which is present in vinegar. Okay, this is the acid which is present in vinegar. Now this molecule is a little different. Here we don't have the metal and the non-metal as such. This is a hydrocarbon. This, by the way, is cation, and this sorry, this is the anion. So sorry, this is the anion, this is the cation. Okay, so this is the hydrogen ion which will be released in solution to give it the acidic property. Okay, and then when it will break into its ions, it will break like this. It will break like this. Now this reaction is reversible. Not all the molecules will give hydrogen ions. Not all the molecules will give. Why? Because the bond is very strong. The bond between the cation and the anion is so strong. Out of 100, maybe only two molecules will give hydrogen ions. Out of 100, if you have total of 100 molecules, for example, only 2 molecules will give us the hydrogen ions. And even those 2 hydrogen ions that have been given can react back react back with the anions to give the molecules again. That is why this reaction, we call it reversible. It can go forward and backward, meaning that out of 100, only 2 will give us hydrogen ions and anions, and even those 2 molecules can react back together to give this again. Sorry, I shouldn't have written this like this, like this. You know, the molecule, this is a molecule. Molecule meaning covalent bonds. Okay, that is why the hydrogen ion concentration does not rise too high. All weak acids behave this way. All weak acids behave this way, meaning that very few molecules give hydrogen ions, and even those hydrogen ions react with the bond with the anion back again to give the molecule back. Okay, because this bond is very strong. So these are called weak acids. Okay, that's that. So 1 hour has passed and I could only do 3 questions. Okay, yeah, that is slow. But anyway, because you know, you guys were not able to recap, you guys did not answer all my questions, and I had to repeat a lot of things. So if you guys please read the chapter before the next class, then that would be very, very helpful. Again, I can go a little faster, but I did not go fast because I did not want to be too fast for students. Okay, if there is any question, confusion, please ask me now. Yes, Shahzeb? Yes?
Teacher, I wanted to ask you that can you send the picture of this page, the answer we have solved in the
In what?
in group of this page, so we know the answers?
Yes, okay, I will send you the questions. By the way, the answers to these questions are available on the net. Okay, you write down answers to Chemistry for You book. Answers of Chemistry for You book. You write that down on the Google search bar, and the first website that you get, you click on it, and you will find the answers to the end of chapter questions of this book. Okay?
Okay.
Okay, another thing, Shahzeb, but I will also send, but I'm not in your group. I'm not in your group. I have sent these answers to Ibrahim Khalil's mother. Maybe Maryam.
All right.
Yeah, I have sent the answers to Ibrahim Khalil's mother. She is, I think, in your, are you in 6C?
No, I'm in B.
Oh, you're in B. Okay. Okay, I will, I don't know how to send you. Okay, but these answers are available on Google, okay? And even the answers to further questions are available on Google.
Okay.
Okay, or you can contact me on my number. Do you have my number? I'll send you private.
I'll ask my mother.
Yeah, okay. Okay. Okay, Ibrahim, you want to ask something? Yes?
अस्सलाम वालेकुम।
वालेकुम अस्सलाम।
जी, इब्राहिम तौसीफ मेरा बेटा है। इब्राहिम खलील कोइंसिडेंस है कि उसके नाम के साथ खलील है। अच्छा, और सेकेंडली शाहजेब ग्रुप में है, तो शाहजेब तक ये इमेज पहुंच जाएगा, डोंट वरी।
Okay. Maryam, I have sent you all those end of chapter questions, and I have also gathered some additional worksheets that I want to discuss with them, but I could not get time today. So, but do forward them. They can read the chapter and also try those questions and come to me in the next class with the questions, with their confusions.
सही है। अच्छा, मुझे ये बताइए, आपने, मैं अभी साथ बैठी हुई थी इसके, तो ये pH 7 है डिस्टिल्ड वाटर की, तो जो प्योर वाटर है उसकी pH हायर होती है या लोअर होती है?
Okay, pure water meaning how many ions are there. If there are ions, then the pH would be lesser than 7, because ions will cause the water molecules to dissociate into hydrogen and hydroxide ions. So
Right.
it is the hydrogen ions which lowers the pH. So when we say pure water, so if that means only water molecules, no ions. See, there's a difference between molecule and ions. Then
Okay.
the pH would be 7. Okay.
Right.
Then the
Right.
pH would be 7 even of pure water. But
Even-
practically speaking, we don't get pure water. You know, the water in the taps is not pure water. It has ions in it.
Right.
Even drinking water in the bottle, Nestle और ये सारे, they have ions in it. अगर आप उस bottle में देखें, ions की list लिखी होती है उस bottle के ऊपर.
Right.
Yeah.
ठीक
जी, ये है.
ऐसे चलो ठीक है, बस मैं उसको कह रही थी कि बेटा ये सवाल कर लेना एंड पे, लेकिन वो शायद थोड़ा सा शायद ही पाएगा.
नहीं नहीं कोई बात नहीं. But you know, for everybody, this is my suggestion. Please read the chapter before attending the class. Please read the chapter, because at least you should have the basic ideas. If you do not have the basic idea, how can I move on? Then I don't like moving on, because I know that grade 6 they have started chemistry for the first time, so they don't know the basics. Many see a child asked me what is a cation and an anion.
Right.
Now
I was there, I was listening to him.
Yeah, you know what the thing is, if he does not know what a cation and anion is, then I don't know if he understood my whole lecture. I don't think he understood, because he didn't know what cation and anion was.
Exactly.
So anyway, so yeah, please suggest to me what topics do kids find difficult. Writing formulae, balancing equations, we can address those issues. I can have one whole class on just writing formulae, one whole class on just balancing equations. Okay.
Right.
So coordinate with them, ask them, and then I can do it accordingly. But first, I will finish these questions. I will first complete these questions.
बेहतर है, बिल्कुल सही. ठीक.
ठीक है?
ठीक है.
Okay.
Okay जी.
Okay, then I'm ending the call. Inshallah, next week, same day, same time, chemistry class. Okay, next week, same day, same time. Inshallah. And we will continue with question number 4. Okay, and I will forward the solutions. Okay, I'm ending the meeting. Assalamu alaikum wa rahmatullahi wa barakatuhu.
Allah Hafiz.
Allah Hafiz.